Alrighty, so today we are on our final set of just solving systems of equations using elimination, and that's going to be where we have to multiply first. So we've talked about elimination, and we've liked it for the most part. It's helped us save some steps and get through it quicker, but it doesn't seem to work for everyone. So today we're going to talk about how we can make elimination work for every system that we encounter. So if I have something like these, 5x plus 2y equals 16, and 3x plus minus 4y equals 20. Looking at this quickly, the 5x and the 3x, I don't know how to, they're not multiples of each other or factors of each other. That's going to be a little harder to figure out. But this 2y and 4y, I know that 2 is a factor of 4, and if I had multiplied this whole thing by 2, then my y's would have the same coefficients. Because if I multiply that whole thing by 2, I'd have 10x plus 4y equals 32. And if I just bring this equation over, I'd have 3x minus 4y equals 20. Well, now look, just by multiplying this first equation by 2, we now have something that we can eliminate. So if we go through here, they have opposite signs. The 4y's have opposite signs, so I'm going to add these together. So 10x plus 3x would give me 13x. 4y plus negative 4y will give me just 0, so I don't have to worry about that. And this would give me 52. Divide by 13, divide by 13, and I get x equals 4. Now I can use that and put it into any of the original equations. I'm just going to put into this one real quick, and I would get 20 plus 2y equals 16. Like we had solved these before, we'd have 2y equals negative 4. I had subtracted 20 to get that from both sides. Divide by 2, y equals negative 2. So my solution would be 4, negative 2. I can check that back in both of them, and I will see that it would work for both, that it is in fact the solution to that system. Let's try another one. 5x plus 2y equals 16. We just did that one. Sorry about that. Let's try the next one. 6x plus 5y equals 19, and 2x plus 3y equals 5. So looking at these, my x is actually, 6 is a multiple of 2. So I could take my x's and I could say, if I multiply this by what will I get 6x's? I multiply it by 3, and my coefficient in front of x would be 6. So I still have this equation here of 6x plus 5y equals 19. And my next equation, my new one, would be 6x plus 9y equals 15. I multiplied this 3 times each of the terms. These 6x's have the same sign, so I want to subtract them. So 6x minus 6x would just be 0. 5y minus 9y would be negative 4y. And 19 minus 15 gives me 4. Divide by negative 4. Y equals negative 1. Put that into one of these original equations. 6x plus 5 times negative 1. It's going to give me negative 5 there, equals 19. So 6x minus 5 equals 19. 6x equals 24, or that should be a 19, sorry, equals 24. So x equals 4. My solution would be 4, negative 1. I could go through and check that in both equations, and I would see that that would be my solution. Let's try another one. This one, maybe try on your own as you're looking to see if you can figure out what you should multiply. So looking real quick, 2 and 7, they are not factors or multiples of each other. 9 and 12, same thing. But there is a least common multiple of both. So you have two options. You can either say, all right, I want to eliminate my x's. And if I decide I want to eliminate my x's, well, the only way to get the same coefficient in front of both of them is to multiply this whole thing by 7 and this whole thing by 2. Doing so, I'd get 14x minus 63y equals 7. And 14x minus 24y equals 46. Subtract them, and I'd get negative 63y minus negative 24 plus 24 would give me negative 39y equals negative 39. Divide by negative 39, and I'd get y equals 1. And going back in, if y equals 1, 2x minus 9 equals 1, 2x equals 10, I would get x equals 5. So there I found the solution that way, and I would get 5, 1. But let's say I found the solution a different way. So let's say, let me go back one. Let's say looking at this, I wanted to eliminate my y's. And I know that 9 times 4 will give me 36 y's, and 12 times 3 would give me 36. Then I would have 8x minus 36y equals 4, 21x minus 36y equals 69. They have the same sign, so I'm going to subtract here. 8x minus 21x would give me a negative 13x. The 36y's would cancel, equals negative 65. Divide by negative 13. Oh, look, what I found is x equals 5. I'll still get the same answer. You can multiply by anything you want. You're still going to get the same answers. It'll just come, you'll get x's first or y's first. So if I had substituted my 5 in for x, I'd get 10x minus 9y equals 1, negative 9y equals negative 9, and y equals 1. So doing that, we can see that it doesn't matter which variable I choose to eliminate. I can eliminate either one, I would still get the same solution. It's going to be totally up to you which one you choose. So let's try one more. So I have 4x plus 5y equals 35. 2y equals 3x minus 9. Just like before, the first thing we have to do is we have to line up our variables. So we would line up our x's. So we have 4x plus 5y equals 35. If I'm moving my x to the other side, I would subtract 3x from both sides. So I would get negative 3x plus 2y equals negative 9. Now looking here, I can choose either my y's or my x's to eliminate. I'm going to eliminate my x's, so I'll multiply this times 3 and this one times 4. When I multiply my top one by 3, I would get 12x plus 15y equals 105. Negative 12x plus 8y equals negative 36. To eliminate my 12x's, I'm going to add these, so they will subtract to make 0. 15y plus 8y will give me 23y equals, what is that, 49? Or 69, I mean. Equals 69. Divide by 23. Divide by 23. Y equals 3. Then we'll go through and put that into one of our original equations. We'd have 4x plus, if I put a 3 in for y, I'm going to have 15 equals 35. Subtract 15. 4x equals 20. X equals 5. So my solution is 5, 3. Again, with all of these solutions we have, you should at least mentally be putting them back in to your original equations to be making sure that they work for both of them before you move on and just assume that you have the right answer. You want to check to make sure you actually do. All right. So we'll give one more a try, and then I'm just going to skip through these couple examples. You're more than welcome to try them. With this one, oh, this one's even not as hard. I know that 2 is a multiple of 6. If I just multiply this bottom one by 3, I would have a common coefficient. So I'd have 6x minus 2y equals 1. Negative 6x plus 9y equals negative 15. I'm going to add these because I would add 6x and negative 6x to make 0. So negative 2y plus 9 will give me 7y equals negative 14. Divide by 7, we get y equals negative 2. If I put that into this original equation, 6x plus 4, because negative 2 times negative 2 will give me positive 4, equals 1. 6x equals negative 3, or x equals negative 1/2. So my solution is negative 1/2, comma negative 2. And so negative 1/2, negative 2 was our solution for that one. So this is another example that you guys can try on your own. And I can let you know tomorrow in class if you're curious about what the solution would be. You can try that one on your own. Same with this one. Okay? So now let's talk about a word problem. So we have Darlene is making a quilt that has alternate stripes of regular quilting fabric and satin fabric. She spends $76 on a total of 16 yards of 2 fabrics at a fabric store. Which systems can be used to find the amount X in yards of regular quilting fabric and Y yards of satin quilting fabric? Sorry about that. So if we look at these 4 options that we have, we know that we need to write a system of equations, so we need the 2 variables, X and Y. And we know that we typically have a cost equation and an amount or quantity equation. So with my cost equation, I'm going to be factoring in these price per yard that we are given. And so for the satin, which they told us that we would call the satin Y and the regular X. So 4x plus 6y equals 76 would be my cost equation. So I can see that in B I have 4x plus 6y, and in C I have 4x plus 6y. Only this one equals 16, not 76, so C can't be right. So I'm leaning towards B being my answer based on my first equation. My second equation should be quantity, so I want the amount of regular plus the amount of satin to equal my 16. And look, if I look at B, it does say x plus y equals 16. So therefore, that would be the appropriate system of equation for this one. We know that this one can't be right because x plus y equals 16 and x plus y equals 76. That's not possible. We already determined why C couldn't be. And then in D, if we look, the only thing that's wrong with D is the variable. So you have to be very careful when I give you variables and I label them for you, that you follow them when you're writing your equations. So the answer would be B. If we wanted to solve that, you could go through and eliminate one of the variables and figure out the amounts of each. Now let's try this one where we're just going to work on it completely. We have to create the equation and solve it. Okay, so a sports equipment store is having a sale on soccer balls. A soccer coach purchased 10 soccer balls and 2 soccer ball bags for $155. Another soccer coach purchases 12 soccer balls and 3 bags for $189. Find the cost of the soccer ball and the soccer ball bag. So they're giving us the 2 pieces of information. By the one coach, $155, and the second coach, $189. So we could say, if I label soccer balls X and bags Y, the first coach got 10 balls plus 2 bags for $155. The next coach got 12 balls plus 3 bags for $189. So if we wanted to figure out how much that costs, I would start by multiplying this times 3 and this times 2 to eliminate my y variable. So I'd have 30x plus 6y equals, now I'm going to have to use a calculator for that one quick. I don't know 155 times 3 off the top of my head. I apologize for this. 155 times 3, 465. And 24x plus 6y equals $378. So now to eliminate my y's, I'm going to subtract. 30x minus 24x gives me 6x equals 465 minus 378 is 87. So divide by 6, divide by 6. The soccer balls cost me $14.50. So I could come up here and say the ball cost $14.50. Now let's see what the bag costs. If the ball costs $14.50, 10 times $14.50 plus 2y equals 155. You're going to get 145 plus 2y equals 155. 2y equals 10. So the bag must cost $5 each. And we could check that using the second coach to make sure it would make sense. So that is how we could solve using a system of equation to figure out exactly what it would cost for each. So that's your lesson for today, guys. I hope you took good notes and came